To hear my voice? Is it
Yes, sir.
okay? Let's start our uh, class. Yesterday, due to some reasons, I cannot take the class, and moreover, we are going to have. I'm already uploaded the question, Unit One, objective type question, in the Moodle, and let me share you the link. Tonight from 7 to 8. From 7 to 8. This one. Let me copy this. And I'll post it in the WhatsApp. Let me post in the WhatsApp. Okay. Tonight from 7 to 8, you have to attempt the quiz, unit test. Okay. Unit test quiz from the unit 1. Then this is a 30 minutes, half an hour duration. Then you have to complete it. This also, I already evaluated your unit test, objective test question also. Then let me upload it in this group. Okay, let's start the second unit. Second unit is physical layer. Last class we already learned about the OSI reference model, and then other topics also, TCP/IP, and then the different types of signals and different types of connecting devices and all. In the OSI reference model, we have 7 layers. Okay, 7 layers. The first layer is the physical layer. Physical layer is concerned with the bit by bit transfer that already normalized, we can say, already prepared from the upper layer. So let's go on through this physical layer. Physical layers concerned with the transmission media first. Let me explain this transmission media. Under this transmission media, we have different types like guided or unguided media. So transmission media is a communication channel that carries the information from the sender to the receivers. We can transmit the information, transmit our data from one station to another stations, sender to receiver. Then what is transfer? It transfer the data. Okay. What data? Data processed from the application layer, received from the application layers, received from the end user, we can say. Then the application layer, this application layer receive this data and process it, and it process to another type of data, maybe in the presentation layer, or it maintain the session or something like this. Then after this, it's forwarded down to this transport layer. Then the next is the network layer, data link layer, and the physical layer. So Data, processed data, you can say processed data is transmitted through the electronic signals. So it transmitted through the electronic signals or in the form of the wave, okay, in the radio. The main functionality of the transmission media is to carry the informations in the form of bits through the lens. So in the form of bits. Bits means you already learned this binary number systems, then bit by bit it transfer it through the local area network. It is a physical part, okay, physical part, physical, not a logical part. This is the physical connectivity part between transmitter and the receiver in the data communications. So it transmit and receive the informations in the physical part, physical layer. In a copper based network, a bit in the form of electrical signals. So copper, a bit in the form of electric signals. So copper can carry only the electrical signals, okay. So it's convert this data bit by bit into the electrical form, okay, electrical form that it transmitted. In a fiber based network, bit is transferred in the light pulse. So in a fiber, it transmit in the light wave, okay, in the light wave, light pulse. So this is called the wavelength, you can say wavelength, light wave. And in the radio signals, here is not included, I'm not included. In the radio wave, it transmits in the form of the spectrum, okay, magnetic spectrum, radio wave. In OSI, open system interconnection phase, transmission media support the layer 1. So it's in the layer 1. Therefore, it is considered to be as a layer 1 component. Layer 1 component, that is the bit by bit transmission of data. Let me look back this unit 1. Let's go on back to the unit 1. What are the things in this layer 1? Let me open it again. Let's recap it. The first layer of the OSI reference model. Okay, first layer of the OSI is concerned with this first layer. Let's look at back this one. This is the bit synchronizations. First is the bit synchronizations. It transferred bit by bit from the sender to receivers. Then it need a clock synchronizations. Okay, if one bit transmit, then the one clock in the first clock one bit transmit, then it's needed to synchronize the clock, the same clock pulse from the sender to receivers, then it send and receive it. And also bit rate controls, how many bit it can transfer it, it's bit rate controls. And the physical layer also concerned with the topology, what types of topology is using, and also transmission mode, what types of mode we are using. Now we are concerned about this transmission media and the transmission mode, okay, maybe in the full duplex, half duplex, all those things. And let's move on to the next point. The electrical signals can be sent to a copper wire, fiber optics, or atmosphere, water, or the vacuum. So that can transmit in the different forms or the different medium, okay. It transmit in the different medium, maybe a copper, or maybe a fiber, or maybe optical, atmosphere, waters, or vacuums. The characteristics and quality of data transmitted are determined by the characteristics of the medium and the signals. So it depends upon the medium and the signals. What types of signal is going to use and what types of medium we are going to use. If it is maybe a space, atmosphere, or maybe a fiber communications, or maybe the copper communications, then it depends on this. The characteristics and quality of the transmissions is determined by the characteristics of the medium, what medium we are going to use and what types of signals we are going to use. Transmission media is two, you can say wired or wireless, bound or unbound. Wired means physical connections like cables and others. Wireless means without wire, it's transmitted through air. Different transmission media have different properties such as bandwidth, delay, cost, and ease of installations and maintenance. So these are the properties of the transmission media. It's depend on the media, that bandwidth, delay, cost, and other things. Okay, installation and maintenance. Transmission media is available in the lower layer of the OSI reference models, that is the physical layer. Some factors needed to be considered for designing the transmission media in this point. Bandwidth, delay, and cost, and all these things is considered. Consider this point. Bandwidth. Last class I already explained what is bandwidth. All the factor remaining constant, the factor of bandwidth of the medium, the higher the transmission rate of a signal. So if the bandwidth is higher, then the higher it's increased the transmitting rate. Okay, bandwidth. But if we have a higher bandwidth, but it depends on the allocations. Okay, say suppose I am having the 10 Mbps broadband. Let's say suppose in a broadband connectivity, so my capacity is 10 Mbps, but the actual transmission is not that point. Okay, it's not come that point 10 Mbps. Maybe that's 1 Mbps, 2 Mbps, or something like that. It depends on our speed. Okay, so bandwidth is the capacity only. Then that's why transmission impairments, we already explained that the different types of impairments are there. There's attenuations, noise, and then the distortions. All these things are the transmission impairments. When the received signals is not identical to the transmitted data due to the transmission impairment. So there are different types of the transmission impairment. Last class we already explained this one. There are three types of impairment: attenuations, distortions, and noise. Plus interference. And interference is defined as the process of disrupting a signal's when it travels over a communication medium on the addition of some unwanted signals. So there are some interference. This also interference is come under this transmission impairment also. This unwanted signals, noise, and other things. Okay, let's see in this graphical representation of this transmission media, guided media, and unguided media. Under this guided media, we have coaxial cable and fiber optic. Under this fiber optics, we can have the two types: single mode and multi-mode type. And also in the twisted pair, we have a shielded and unshielded twisted pair. And under the guidance, we have microwave, radio wave, infrared. All these things comes under this unguided media. So guided is the wired connections, physical connections, and unguided means without physical connections. This is the wireless. All are wireless. So let's see in the point by point in the guided media. It is defined by the physical mediums through which signals are transmitted. It is also known as the bounded media. Types of the guided media. Number one is the twisted pair. Okay, twisted pair. What is twisted pair? Twisted is we have to twist cable. This is called the twisted pair. This is in the physical medium made up of the pair of cables. The inner core is the copper, and outer we are having the plastic insulator to protect the line between the two pairs of cables. And then the twisted pair cable is cheap as compared to other transmission media, so it's very cheap, that pairs of cables for in terms of the installations. And also very easy to install this one. Nowadays also we are still using this twisted pair cables in the LAN or in this router network also sometimes. The frequency range for twisted pair cable is from 0 to 1.3 kilohertz. Okay, that frequency. Twisted pair consists of two insulated copper wire arranged in a regular spiral. So it's very clear that it's twist the two pairs of cables in a spiral pattern. The degree of the reduction of noise interference is determined by the number of turns per foot. So number of degree to reduce the noise of interference. So if this is not a twist, then if this is parallel, then there's lots of interference between the two pairs of cables. So to reduce this one, we need to twist the pair of cables. So the degree of reduction of noise of interference, how much noise we have to reduce in the pairs of cable, then this is number of turn per foot. 1 foot, how many turns we are going to use, that determines by the noise reductions. Okay, and increasing the number of turn per foot decrease noise interference. Okay, this is very clear that here we have two pairs of cables. Here in the inner core is the copper wire. Here we have insulators. After is the jacket. We are having this plastic jacket. Under this twisted pair, I hope that you already know this network cable. This is the network cable. Under this twisted pair cables, we have shielded and unshielded. UTP is the common one. Unshielded twisted pair is very cheap and very easy to install, very easy to crimp, and very easy to manage this type of cables. Under these UTP cables, we have 4 pairs of cables. Then the number of cables available in this is 8. If it's 2 pairs of cable, then it's come 4 pairs. Okay, so each and every cables having the 3 types of color with solid and stripe color: blue, orange, brown, and green. Okay, blue, orange, brown, and green, and all these colors is comes along with solid and stripe. Okay, internally is having this copper wire. This is the actual cable for transmitting the electrical signals. Okay, electrical signals. So if there is no insulator, then it will collide with each other. So this is the example of the twisted UTP cable. And in the shielded type, okay, shielded twisted pair cable, at the outer core, it's having the copper mesh for grounding the twisted pair. So what is the difference between this shielded and unshielded? Shielded cable and unshielded cable is that the difference is that it's reduced the noise and interference, and also it increased the length of the cable length, the transmitting length of the cables. In UTP, we can transmit the data without amplification, without attenuations. We can say without attenuations, we can transmit around 100 meters only. So beyond this, it reduces the signals and lots of noise are there. Then the communications errors is coming up in this beyond 100 meters. But in this STP, we can transmit beyond 100 meters, like 200, 300 meters without amplifications, without error. Why? Due to the shielded. Okay, this shielded remove the interference. Okay, remove the interference of the signals. Okay, shielded twisted pair, unshielded twisted pair is widely used in the telecommunications and also in this computer network. Falling under red categories of the unshielded twisted pair cable is the category 1, 2. Okay, there's different types of categories are there. Category 1 is used for telephone lines, And low speed data category 2 can support maximum sorry, up to the 4 mbps, and the category 3 can support up to the 16 mbps. Category 4 can support up to the 20 mbps, therefore it can use for long distance communications. And category 5 it can transmit up to the 20 mbps, and category 6 can be transmitted up to the 100 mbps or something like this. Okay, so based on these categories, then we can transmit data. Advantages of the unshielded twisted pair is that it's cheap. Installation of the shielded unshielded twisted pair is easy to install, and can be used for the high speed LAN connections. Nowadays we are still using this twisted pair cables for the local area network, plus for this metropolitan area network also. Then what is the disadvantages? This cable can only be used for the short distance because of the attenuations. So this attenuations we already explained, that the uh, loss of powers. Okay, so we cannot transmit a longer distance. Then if it is too long, then beyond 100 meters, then it can lose the power. Okay, so if it lost the power, then sorry, if it slows the power, then it's create the problems in the receivers. Okay, so it's susceptible, sorry, not susceptible, it's disadvantage. One of the disadvantages is the it cannot transmit the data in the longer distance. Okay, transmit only the short distance, 100, up to 100 meters. See that twisted pair. See that twisted pair is a cable that contains the mass of surrounding wire that allows higher transmission rate. So it can transmit higher bandwidth of data. And the characteristics of this shielded twisted pair is that the cost of the shielded twisted pair cable is not very high and very low. Its installations of STP is easy as compared to this UTP is a little bit complex. Okay, and it can higher capacity and compare with the unshielded cables. So it's having the higher capacity and distance also. It has the higher attenuations. Okay, power loss is very less. Okay, we can transmit longer distance, higher attenuations, and it's shielded that provide high data transfer rate. And let's go to the disadvantages. It's more expensive as compared to the UTP. This STP is more expensive. Why? It's having this own ground cables, copper mesh shielded. Okay, copper mesh shielded, and also it has the higher attenuation rate. So this is the UTP cables. Okay, UTP cables. Under these UTP cables, we are having this two types: unshielded and shielded type twisted pair cables. And let's move on to the coaxial cable. Why we are not using this coaxial cable in the local area network? Is it not possible or possible? It's possible. We can use it for LAN, but why we are not using? We are not using due to the expensive. Okay, it's expensive as compared to the UTP. So you need a separate graphic network to plug in this coaxial cables, and also we have to have junctions. Okay, BJT junction connections. So it's bit expensive. So coaxial cable is very common used in the transmission media, for example TV, where is usually a coaxial cable. In the cable TV, it still use this coaxial cables that it can transmit lots of data then without amplifications. So it's still used in this cable TV. The name of the cable is coaxial cables, and it can contain two conductor parallel to the each others. So it can have a higher frequency as compared to the twisted pair, so we can transmit longer distance and higher attenuations, all these things. The inner conductor of the copper coaxial cable is made up of copper. So the inner part is the copper, and outer core is made up of the copper mesh. So here we have a shielded of copper mesh. The middle core is made up of the non-conductive cover that separate the inner and outer core. So this inner and outer, that we need as separators, okay, insulators. So we have insulator of this one, and then the middle core is responsible for the data transmitting, where the copper mesh prevent from the EMI. So here we have in the middle we have a copper connections. Okay, in these copper connections, we transmit the data, the real data. We transmit the real informations here, real data, and then outer of this we have copper mesh. Okay, this is protected from the EMI, electromagnetic interference, you can say EMI. All those copper based transmission media is base, it is susceptible, you can say. It can how to say, disturb the signal, the data, by the EMI, electromagnetic interference. All these copper transmissions can be interfered by the can be disturbed by the EMI. Okay, twisted pair also susceptible by this EMI also. This coaxial cable also is susceptible. And this is the graphic one, coaxial cable. Here we insulator, then out of this we have a copper mesh, then in between this we have insulators, then inner core is the copper, then the real data is transmitted in this copper, then this is for the protection from the EMI and all these things. And then coaxial cables of two types, baseband transmission and broadband transmission. It is defined as the process of the transmitting single signal at a high speed. So in the baseband we can transmit only the single signals, and broadbands defined as the process of transmitting multiple signals simultaneously. In this broadbands we can transmit different types of data. Okay, we can transmit it. And then the next point is advantages of coaxial cable. The data can be transmitted at a high speed. It has better shielding or compared to a twisted pair cable. It provides higher bandwidth. So the advantages is that the data can be transmitted at a high speed. It has better shielding as compared to the twisted pair. So that it's sealed with a copper mesh ground cable. Okay, and also it's provide higher bandwidth, the speed. Okay, the transmitting speed is very high as compared to the UTP. Disadvantages of this coaxial cable is that it's more expensive as compared to the twisted pair. Is more expensive. If any fault occur in the cables, the failure of the entire network. So there are some cable failures, then the entire networks fail. There is no backup cable or something like this. But in the UTP cables, we have a multiple of 4 pairs of cables. So if network cable downs, then it can manipulate. It can manage. We can manage it by others. Okay, other cables for transmitting the data, and also is susceptible by this EMI. Don't forget this one. Disadvantages. One of the disadvantages. That's one. Okay, these are the points under this coaxial cable, and move on to this fiber optic cable. Apart from this copper base transmissions, fiber optic transmit the data in the form of light. Okay, in the fiber cable. Fiber optic cables that can use electrical signals for communications. Okay, fiber cables is a cable that uses electrical signals for communications. That's we have to remove it. No, this one. Fiber cables can hold optical fibers coated in a plastic that are used to send and receive data by pulse of light. So this is the point. The point number one, we have to remove it. In your, if you download the note also, just remove it, the point number one. Okay, not in the form of electrical. Okay, not in the form of electrical. That it transmits the signal in the form of light in the fiber cable. The plastic coating protect the fiber from the heat, cold, electromagnetic interference from other types of wear. So it's needed to protect those things, and the main thing is the it does not interference. Actually, does not interference by this. The advantage is that no interference with the electromagnetic in the fiber optic. Okay, let's move on. Fiber optic provides faster data transmissions than copper wire, so it's very clear. It's transmit the data in the form of light. Okay, in the form of light. Let's see here in the graphical type that we have different types of core in the fiber optics. In the one cores we can have 26 number of cables. In the two core cables also we can have 12 pairs 12 fiber optic cables like this. Based on this core we can have, but let's see the cable configurations. Core is there, cabling is there, jacket is there. Okay, core is the center core. Okay, this is the center core, this end view, this center core. Then here we have a cabling, then outside we have a jacket. So the actual data is transmitted in this. Okay, actual data. Let's see the basic elements of this fiber optic cable. That this optical fiber cables consist of narrow strand of glass or plastic known as a core. So we can have glass base fiber optic and plastic base fiber optic cable. A core is a light transmission area of the fiber. The more the area of the core, then more light will be transmitted in the fiber. So here we have transmitted the data in this core of light. Cabling. What is cabling? The concentric layer of glass is known as the cladding. The main functionality of the cladding is to provide the low refraction index of the core interface as to cause the reflections within the core and that the light wave are transmitted to the fiber. So let's see the fiber optic in this Google. Oh, sorry, cladding. So light signal are transmitted in this form. Okay, so we have this transmission is based on the reflection and refraction, reflective index and refractive index. So I hope that you already knows that what is refractions and what is reflection. So this will cause refraction and reflection cause the error in the transmission at the receiver. So to remove those index, we have a Kerling. Kerling curve the refractions. Okay, refractions. So here we have an inner core, then here it's cross the core in the Kerling. Okay, it crossed the core in the Kerlings, then this will reduce the refractive index. Okay, so the main functionality of the Kerling is to provide low refractive index. The refractions coming up is refract properly, but there are some refractions causes the noise at the receiving end. So that's why we have a cladding to having the low refraction rate at the core interface as to cause the reflections within the core as the light wave are transmitted to the fiber. So this scattering is very important to reduce the error at the destinations. Okay, jacket. To protect this fiber optics, we need a jacket. The main purpose of this jacket is to preserve the fiber strength, observe shock after and extra fiber protection. So the fiber core is very small. It comes inside of your hair. Okay, a single hair. So it's very susceptible. It's very easy to break and easy to spoil the signals. So we need a very strong protections. This is called the jacket. Jacket protect the fiber optic cable. Okay. Following are the fiber optic cable over copper. Greater bandwidth, it's very clear, it's having the greater bandwidth. Faster transmission speed is very clear, it's very fast. This electrical speed is faster than not faster than the light speed. Light speed is the it transmit the in the light speed, it transmit data in the light speed, that's why it's very fast. Longer distance means electrical signals we have to amplify it at some points in the low distance. Okay, in the low distance we have to amplify it, but fiber is you can transmit it in the light, in the form of light, that it can carry the data at the longer distance. Okay, and better reliability. So fiber optic cable is more reliable than copper cables as it is immune to any temperature changes, where it can cause obstructions and conductivity at the cables. So it's not susceptible by the EMI, also electromagnetic interference, and also thinner and sturdier. Fiber optic cable is thinner and lighter in weight, so it can withstand more pull, pressure, and copper cables. So these are the points: thinner and sturdier, and better reliability, and longer distance, faster speed, and greater bandwidth is the advantages of the fiber optic communications. Okay. Okay, let's done up to this. unguided media. Next class we'll continue to this unguided media.